Hello, I'm Karam. My partner is Jenny, and we're going to be discussing parallelism. I'm going to be discussing an introduction to parallelism and an in-depth explanation of parallelism, while my partner is going to be discussing the rest. So, parallelism is the process of a computer running multiple tasks simultaneously. It's typically based on the fact that a large problem can be broken down into multiple smaller chunks, and then those chunks can be operated upon by multiple computer resources simultaneously, which causes a drastic decrease in the execution time. There are different types of parallel computing that are available for us to choose. These include bit-level parallelism, data parallelism, instruction-level parallelism, and task parallelism. In the area of high-performance computing, parallelism has been employed considerably, but due to physical constraints that prevent scaling without parallelism, it's gained a lot of interest outside of high-performance computing. Since it's becoming a lot more difficult to reduce the size of processors, and because of the heat generation that affects the performance, parallel computing has formed the core of modern computer architecture, and especially in the form of multi-core processors. And on the illustration to the right, this is a demonstration of what parallel processing looks like on the right, and then serial processing looks like on the left. So in a serial architecture, you would have the customers or the computing tasks be performed sequentially, one after the other. Whereas on the right, you would have these customers or computing tasks being performed simultaneously. So that's a huge and obvious increase in performance. So I'm going to go into the in-depth explanation of parallelism. So there's two main classes of parallelism and applications that we're going to be discussing. There's data level parallelism, which results from many data items that can be processed simultaneously. And then we have task level parallelism, which results from many instructions simultaneously processed against a data item. So understanding data level parallelism would be if we consider a two-processor system labeled CPU A and then CPU B, and we want to perform a task on a piece of data labeled T. The way this would work under data level parallelism is to instruct CPU A to work on a particular task on one part of T, and to have CPU B work on that task on another part of the data T. The data can be assigned using conditional statements like if then or if else. And then we're going to go into task level parallelism. So it's also called function or control parallelism. This is a form of parallelization of code across multiple processors in a parallel computing environment. So let's consider the example of a two-processor system running some code labeled CPU A and CPU B, and that are executing tasks A and B respectively. We can instruct CPU A to perform task A, and at the same time instruct CPU B to perform task B.
Hello everyone, this is Jeannie. I'll be talking about the limitation, advantages, and disadvantages of parallelism. First, let's take a look at the limitations. In an ideal world, everything is perfectly parallelizable. Everything will be starting at the same time and stop at the required time. But in reality, the program is made out of non-parallelizable parts and the parallelizable parts. The percentage of the serial parts composed in the program dictates and limits the maximum speedup that the parallel computing could do. This is called the Amdahl's law. This is about how much a computation could be sped up when running the parallelizable parts in a program. When you look at the graph over here, you can see that the speedup is determined more by the fraction that can be parallelized over here. So you got 50, 75, 90, and 95, then by the number of processors. As a matter of fact, even if we're using more than 60,000 processors over here, the speedup is never greater than 20. over here. This is the limit 20. As you can see, this is the serial parts, and this is the parallelizable parts. We can fold this into smaller parts for the parallelizable parts, but here's the length. It can be small, infinitely small, but this will still be a big chunk, which affects the speed up. Another limitation is the communication cost. The communication cost occurs when programming breaking down into smaller tasks, as well as smaller tasks bringing back to a solution. So this is the problem over here, and this is the tasks, and this is the solution. The solution also called as the outcome. This is the communication time. Say, oh, we need to break down into smaller parts. How small? How many parts? And this is the communication cost that say, oh, we're gonna grouping back. The communication cost may sometimes be greater than the execution cost. This basically means that time spent on communicating how to divide or combine a task is longer than getting the task done. This will be significant when the problem becomes greater and more complex, causing communication overhead and affects the performance of parallel computing. Then we'll look at the advantages and disadvantages of parallelism. There are two distinctive advantages of using parallel processing over serial processing. Reduce time and save money. It saves time and money. There are multiple processing elements collaborating to solve problems. A problem is broken down into several smaller tasks as shown before, which would then be taken care of by different respective processing units. An analogy would be eating a whole pizza on your own. So this is your pizza, and then it is so difficult and challenging to finishing one pizza by yourself. Because you're gonna eat everything over here. While parallel processing is more like having a group of friends dividing the pizza into different slices. So we have 8 slices here, and then each of your friends will take one piece, and we can finish it fast and easy. Resources like friends are working together and reducing the cost and time. If you're eating alone, so serial processing, it will take a long time to finish the pizza, and you'll feel really bad afterwards. Parallel processing could also be a better choice when solving larger or complex problems, since it can break down problems into multiple smaller tasks. It is able to solve problems faster in comparison to serial computing. Thus, it has a better cost per performance in the long run, as Benjamin Franklin once said, time is money. Now, we'll look at the disadvantages of parallelism. Although parallelism seems to be a problem solver to almost everything, it saves time and money, it works great when solving big and complex problems, etc. Parallel processing sometimes could not be implemented due to the nature of problems. For instance, someone could eat a sandwich while walking on the street. This is the parallel processing. But we cannot speak while eating. It has to be concurrency, doing one after another, not parallelism. Communication cost is discussed in the limitation of parallelism section, and this is also a possible disadvantage. The core idea of parallelism is breaking down problems into smaller pieces and then finish them quick and combine them to form a solution later. What if there's an error in the communication? What if there are too many communications happening and slows down the speed? Also, how to ensure all the tasks are running smoothly and are able to synchronize perfectly to come up with a solution at the required time. There is a lot going on in parallel processing, so it will be difficult to debug when an error occurs. Also, considering the complexity of parallel computation to serial computation. Parallel computation requires more human efforts when developing it. So that's all for today. Thank you for watching. Bye bye.